Here's pre-calc problem 10-56. If g of x equals x times x plus 2 times x minus 3, where are the vertical and horizontal asymptotes of 1 over gx? So that's the reciprocal of gx. For the horizontal asymptote, evaluate the limit as x approaches infinity of 1 over gx. So if I put gx in this denominator, there's going to be certain numbers that will cause this denominator to equal 0, and those numbers would be 0, -2, and 3. So we can't divide by 0, so if I, had a graph or something, I would have to make these asymptotes to prevent, like, I think you've seen graphs of rational functions. These asymptotes prevent us from plugging numbers in that would give us a 0 denominator. So the graph won't go it won't go to the places where there's going to be a 0 denominator. It'll do things like, maybe it'll go like this or something. I mean, I'm not sure. I didn't graph this one, but it'll basically, when you have a 0 denominator on a rational function, you can just set that denominator, which is this, equal to 0, and you can get your vertical asymptotes. Okay, your horizontal asymptote, if the degree of the numerator, like this would just be like x to the 0, the degree of the numerator is less than the degree of the denominator. The degree of the denominator would be, it's a third degree, right? Because it's x times x times x, that's like x cubed. So your horizontal asymptote is going to be y equals 0. So that might make sense if you think about what happens when, I think that's why they asked you this. If x goes to infinity, then what's going to happen to y? So remember, I have 1 over x times x plus 2 times. As x goes to infinity, this bottom will get really, really big, because infinity minus 3, that's still a huge number, times another huge number, times. This is going to be a fraction. It's like 1 over some giant number, so it's going to tend towards 0. Okay, and so since it tends towards 0 but never gets there, that's why there's that horizontal asymptote there. Hope that makes sense.